This simulation is going to help us to understand a Kelvin temperature scale and the idea of absolute zero. So you have two different kinds of containers. At first, on the right, you have a container that has a fixed volume, just a like a cylinder or gas tank, and the volume doesn't change. And you have a gas. You're looking at gas molecules inside this gas tank here. And a second container is what's called a piston, where the upper lid can move up and down here. But in both cases, though, what you're looking at is gas molecules on the inside of these containers. And so what we said before is that what temperature is pretty much, it characterizes how fast gas molecules move. So if you look at it both cases, the gas in both of these containers, they move at about the same speed. And the reason why is that they're both at about the same temperature. And as you increase the temperature, you notice in both cases that the gas molecules are moving faster. So again, the bigger the temperature, the faster the gas molecules move. And the lower the temperature, the slower the gas molecules move in both of these cases here. So again, what temperature is, it just tells you how fast gas molecules move. So there's a special temperature scale called a Kelvin scale. And what happens here is that here the simulation doesn't really show it to you, but ideally there should be a temperature where so here we're at the minimum temperature that we can reach on this scale here. So in this case, even though we're at the minimum temperature, there's still motion happening in both of these cases there. So to better describe what happens inside of, for atoms, we're going to introduce a new temperature scale called a Kelvin temperature scale. And in this Kelvin temperature scale, what happens is that at 0 kelvins, all motion is going to stop. So this simulation doesn't show you that here, but in this Kelvin scale is defined as at 0 kelvins, all motion stops.